Okay, welcome back. This is Mr. Hassan's Maths channel. This is question number 8, part D, from the June 2022 Cambridge paper 4 variant 2 of the 0580 IGCSE extended syllabus. And this question is about how to solve a pair of simultaneous equations where one of them is of non-linear. This is 5x plus y squared equals 39. That's non-linear. So in this case here, what we want to do is we want to try to rewrite the equation in such a way that we have everything in terms of just x or just y. Now I can see here that one way of doing that would be by using a type of substitution, okay? Or we could even do it using some sort of elimination. I'll show you both ways and then we'll get to the same equation. So I'll split the page into two parts. So on this side, what I can do is I can see that in the first equation, x is easily made into the subject. So x is equal to 12 minus 2y. And then what I can do is I can take the second equation and substitute instead of x, 12 minus 2y. So I can write instead of 5x, I can say 5 times 12 minus 2y. That 12 minus 2y takes the place of the x. Then you got plus y squared equals 39. So you end up with 5 times 12, which is 60, minus 5 times 2, which is 10, so it's 10y, plus y squared equals 39. So you end up with an equation, y squared minus 10y, and you've got 60 minus 39, which is going to be that's going to be 21. Equals 0. So you have this quadratic equation which we can then solve for y. All right, and then I'm going to show you how to solve that now, but first of all I'll get to the same stage by dealing with the question in a slightly different way, and that is by using elimination, where I can say take this first equation here and multiply the whole equation by 5 to make the x's have the same coefficient. So this is going to give you 5x plus 10y equals 60, and this is 5x plus y squared equals 39. So now if you subtract these two equations, okay, and I'm going to subtract them this way, okay, then you have 5x minus 5x, which is 0. You have y squared minus 10y, which you can't do anything with it, so you can just write y squared minus 10y, and you have 39 minus 60, which is minus 21. So you end up with y squared minus 10y plus 21 equals 0. So either way, you end up with this equation, y squared minus 10y plus 21 equals 0. And then we can go on to solve this by factorizing. So you can see that both of these two numbers multiply to give you 21. So you have y, and you have minus and minus. They both have to have the same sign, and add to give you negative numbers, so both negative, and multiply to give you positive numbers, so it must be both negative. And two numbers multiply to give you 21, and add to give you 7, well that's 3, add to give you 10, sorry, that's 3 and 7. So y minus 7 and y minus 3, those are the two factors. So we say we can say either y minus 7 equals 0 or y minus 3 equals 0. So y is 7 or y is equal to 3. And then we can use one of the two equations. I've already written here x equals 12 minus 2y. So I can now say when y equals 7, x equals 12 minus 2 times 7, which is 12 minus 14, which is negative 2. And when y equals 3, x equals 12 minus 2 times 3, which is 12 minus 6, which is 6. Okay, so we can say that we have x equals minus 2 when y equals 7, and x equals 6 when y equals 3. And there we have our solutions to this problem, which we could, if we wanted to, make sure by substituting the values in. So you can try minus 2 and 7 first. Minus 2 and 7. You're going to have minus 2 plus 14. That gives you 12, that's correct. And minus 2 times 5 is minus 10 plus 49. Minus 10 plus 49 is 39. That also works. And we can also use the other values, which are 6 and 3, to see that they also satisfy both equations. X equals 6, that's 6 plus 2 times 3, 6 plus 6 is 12, that works. And x equals 6, 5 times 6 is 30, 30 plus 3 squared, 9, 30 plus 9 is 39. So both of these pairs of values work for both equations. So we know that we have got the right solution. Okay, so that's one of the students was asking how to answer this question. I've saved this as a separate question from the rest of the question. So if I'm asked to answer 8A, B, C, or E, I will answer them in separate videos. I'll just save this under solving quadratic simultaneous equations. Okay, so other questions from this paper can be found in the playlist that will appear in this section over here. Other questions from this topic of quadratics, I guess, from IGCSE Cambridge can be found in this playlist over here. You can subscribe to my channel by clicking on this link, and the video that shows over here will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.